Welcome to u-Substitution. So recall in our last video, we did quite a few chain rule problems and then showed the corresponding integral. So recall if we had, let me change colors. So we had previously, if we wanted to take the derivative of f, I'm going to use u since that's what we've been working with. Right? If we wanted to take the derivative with respect to x of f of u, that was f prime of u times du dx. And then we were showing that we could do the equivalent integration fact. So if we have instead an integral of f prime of u times du dx, and then dx, we can then say that this is simply f of u plus c, essentially is what we are working with. So the idea here is if we have an integral that we don't know right off the top of our head, it's not a usual integration fact, we may be able to manipulate it so it takes this form. So if we have an integral in x that is not a basic integration fact that we know, we may be able to manipulate it into this form. And I'm not going to write it exactly in that way. I'm just going to write it in the form integral of, let's use g of u times du dx, where integral of g is one we know. So we're essentially trying to force a chain rule to appear so we can undo it to integrate. So for an example, let's consider cosine of 3x squared plus 4 times 6x dx. So just some things to keep in mind. We know the integral of cosine of x dx. We don't know what to do when there's something else inside the cosine. So presumably, the thing that's going to be our u is that piece inside of our cosine. So we'll set this piece inside as our u. So we know this one, cosine of 3x squared plus 4, right? Complicates things. So what we're going to do again is let's go ahead and set 3x squared plus 4 to be our u. Okay. So we have a cosine of u in our function, and we have du dx would be 6x. So we have the integral of cosine of 3x squared plus 4 times 6x dx here. Well, cosine of 3x squared plus 4, that 3x squared plus 4 is u, and this is du dx. So we are really just looking at an integral of cosine of u times du dx, and then dx. So we will just integrate cosine, and cosine goes to sine, of u plus c. And then plugging back in our u, this is sine of 3x squared plus 4, and then plus c. So we were just sort of pulling out the chain rule from the problem we were given. So let's go ahead and take a look at another such problem. So we want to find the integral of e to the sine of x, cosine of x dx. So once again, we have an e to the sine x. Sine of x is e to the sine x is a composition. That's where we want to focus. So let's go ahead and set u to be sine of x. And that means that du dx would be cosine of x. This looks promising, right? So we have the integral of e to the sine of x, cosine of x dx is equal to the integral of e to the u times du dx times dx. This integral we know, right? This just becomes e to the u plus c, or plugging back in, e to the cosine of x plus c. All right, let's go ahead and do one more, and I'm going to slightly change notation this time around. And this new notation will be kind of the official u-substitution notation. So here we want to find the integral of 1 over 5x plus 1 dx. And 5x plus 1 appears to be sort of the inside function out of 1 over u, say, right? So we're going to go ahead and set u equal to 5x plus 1. We know how to integrate 1 over x. We haven't worked with anything else yet. So u is equal to 5x plus 1. That means du dx is simply 5. And then just a quick reminder, we did differentials previously, and the differential du was equal to du dx times dx. And so du is equal to 5 dx. If u equals 5 dx, then we can solve instead for dx. So we're now going to solve for dx. The reason I'm doing this is because our original integration fact doesn't have a 5 dx in it. It just has dx. So if we solve for dx, again, since the integral of 1 over 5x plus 1 dx has no 5 dx in it, okay, then what we wind up getting is that 1/5 du is the same thing as dx. So if we're then going to back to our integral, what we have is our integral of 1 over 5x plus 1 dx is the same thing as the integral of 1 over u, and then dx is 1/5 du. So I'm looking at the integral of 1 over u times 1/5 du, otherwise known as 1/5 times the integral of 1 over u du. This then becomes 1/5 times the integral of 1 over u is the natural log of the absolute value of u, and then we have our plus c. And so we get 1/5 times the natural log of the absolute value of 5x plus 1 plus c. So when we do our integration, plugging in u's, this is what is called u-Substitution. So this whole process here is u-Substitution. And we're essentially forcing a chain rule to appear. Sometimes if there are missing constants, that's okay, because we can always multiply or divide by a constant to counteract dividing or multiplying by a constant. So we wind up with, again, that 1/5 times the natural log absolute value of 5x plus 1 plus c.